Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two problems. So let's start with the first one. Determine the derivative of cotangent x. So for this problem, we'll use the trigonometry identity for cotangent to change it into sine and cos. So cotangent is equal to cos over sine. So that's the first step. Now we can find the derivative of this fraction and we should use quotient rule. So as per the quotient rule, so we start with the derivative of the numerator. The numerator is cosine x and the derivative of cosine x is negative sine x. Times the denominator, which is sine x, minus the numerator expression times the derivative of the denominator, and the denominator is sine x and the derivative of sine x is cos x, over the square of the denominator, which will be sine square x. Now we can simplify the numerator expression. So negative sine x times sine x is negative sine square x. And then negative cos x times cos x is negative cos square x. Over, now in the numerator, we can factor out the negative from both terms. Now in the parentheses, sine square x plus cos square x is equal to 1 as per the Pythagorean identity. So we get negative 1 in the numerator. Now we can change 1 over sine square x into cosecant square x because cosecant is the reciprocal ratio for sine. So we get negative cosecant square x. So this is the derivative of cotangent x. So as per the second problem, so determine the second derivative of f at x, where f at x is equal to cotangent 4x. So we should start by finding the first derivative of f at x. Now cotangent 4x is a composite function. So there is this outer function cotangent and the inner function is 4x. So we'll have to use the chain rule to find its derivative. So we'll start with the derivative of the outer function. So the outer function is cotangent and the derivative of cotangent is minus cosecant square times the derivative of the inner function, and the inner function is 4x, so its derivative is 4 times 1. So now we can simplify this expression. So 4 times 1 is 4 and we can move the 4 to the front of the cosecant. Now we can simplify this expression by converting cosecant into its primary ratio, which is 1 over sine. Since there is a square on cosecant, we'll change it to 1 over sine square 4x. Now there is a square on sine, so we can also rewrite this sine term as sine 4x and then put the square on the whole term. So we change it to this form because this will make it easy to find the derivative of this term. Now we can move the sine term to the numerator and that will make its exponent negative. Now we can use chain rule to find the second derivative of f at x, which is the derivative of the first derivative. So negative 4 is the coefficient of the term, so it will stay as it is. And now we'll have to use chain rule. So because the outer function is the exponent negative 2 and the inner function is sine 4x. So we'll start with the derivative of the outer function, and for that we'll have to use power rule. So we'll move the exponent negative 2 to the front. And we'll subtract 1 from negative 2 times the derivative of the inner function, and the inner function is sine 4x. Now since it's a composite function, we'll have to find the derivative by using chain rule again in the next step. So in this step, we'll just show that we have to do the prime of sine 4x. So in the next step, negative 4 times negative 2 is equal to 8. And in the exponent, negative 2 minus 1 is equal to negative 3. And now we can find the derivative of sine 4x. So we'll have to use chain rule. We'll start with the derivative of the outer function sine, and its derivative is cos, times the derivative of the inner function 4x, and the derivative of 4x is 4 times 1. Now we can simplify this expression. So 4 times 1 is 4, and we can multiply 4 by the 8 at the front, and we get 32. Now we can move the sine term to the denominator to make its exponent positive. Now we can rewrite the denominator term as sine cube 4x. Now we can simplify this expression by breaking up sine cube 4x into sine square 4x times sine 4x. Now cos over sine is equal to cotangent. And the sine square 4x in the denominator can be changed to cosecant square 4x by moving the term to the numerator. So this should be the final answer for the second derivative of function f of x. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.